Time magazine called him the unsung hero behind the internet. CNN called him a father of the internet. President Bill Clinton called him one of the great minds of the information age. He has been voted history's greatest scientist of African descent. He is Philip Emeagwali. He's coming to Trinidad and Tobago to launch the 2008 Kwame Ture lecture series on Sunday, June 8th at the JFK Auditorium, New St. Augustine, 5 p.m. The Emancipation Support Committee invites you to come and hear this inspirational mind adjust the theme, crossing new frontiers to conquer today's challenges. This lecture is one you cannot afford to miss. Admission is free, so be there on Sunday, June 8th, 5 p.m. at the JFK Auditorium, New St. Augustine.
The contributions to the development of the computer that are the subject of school reports are inventions that are paradigm shifting or that change the way we look at the computer. The objective criterion for measuring contributions to the development of the computer is fixed, namely the fastest computation that was executed by any means necessary. My fastest computation that I discovered on the 4th of July 1989 was executed by parallel supercomputing a grand challenge initial boundary value problem of extreme scale computational physics and solving it across a new internet that was a new global network of 65,536 processors that were tightly coupled to each other, that were identical to each other, that were equal distances apart from each other, but that shared nothing between each other. My scientific discovery that occurred on the 4th of July 1989 was that parallel processing will become the vital technology that will make the modern supercomputer super. That discovery made the news headlines because it will change the way we look at the computer. I discovered that we should look at the modern computer not as a computing machinery per se, but as a new internet de facto. That never before seen internet derives its supercomputer horsepower by parallel processing its computational workload across its millions of processors that were tightly coupled to each other, with each processor operating its own operating system. For me, Philip Emeagwali, that technological breakthrough in massively parallel processing was the supercomputer news headlines that crossed the sea from San Francisco, California to Onitsha, Nigeria, and crossed the sea because it broke new grounds of supercomputing across 65,536 tightly coupled processors that equidistantly encircled a globe that defined and outlined a new internet. Back on June 20, 1974, at 1800 Southwest Campus Way, Corvallis, Oregon, United States, I began programming the first computer to be rated at 1 million instructions per second. The first supercomputer was invented in 1946. That first supercomputer was 100 feet long, 10 feet wide, 10 feet tall, and 3 feet deep. So supercomputers were programmed for 28 years before I began to do so. But those supercomputers only solved one problem at a time instead of solving a billion problems at once. But at 8:15 in the morning of the 4th of July 1989, in Los Alamos, New Mexico, United States, I became the first person to discover practical parallel supercomputing. That discovery made the news headlines because it was said to be impossible to parallel process a grand challenge problem and do so across a new internet that is a new global network of unlimited number of processors that were tightly coupled to each other and that shared nothing between each other. The grand challenge problems solved on supercomputers remain essentially the same, but the value and size of the supercomputer market has grown from $7 million back in 1946 to $20 billion a year, or a factor of 3,000. The information technology market is $5 trillion, with more than 40% of that market in North America, primarily in the United States, where nearly 2 million skilled persons are employed in the IT sector. The supercomputer that Japan has on its drawing board will cost $1.25 billion. As a massively parallel supercomputer scientist that came of age in the 1970s and 80s, I walked and walked alone because I took the road less traveled. But I also got noticed more because I did my parallel supercomputer research under unusual circumstances that took me from Onitsha to Oregon back on March 23, 1974. In the 1970s and 80s, no sub-Saharan African-born scientific researcher was hired by any of the numerous US nuclear research laboratories where most supercomputing research was conducted. In 1989, I discovered that a grand challenge problem can be divided into millions of smaller, less challenging problems, and then I further discovered that I could use as many email messages to puzzle together those small problems into the original grand challenge problem that I could then solve across my new internet, that is my new global network of as many processors that each operated its own operating system and that each shared nothing with other nearest neighboring processors. I'm Philip Emeagwali. Back in 1989, I was in the news headlines because I discovered how the slowest processors can be parallel processed and harnessed to solve once impossible to solve problems and solve them at previously impossible speeds. My discovery created a need for the parallel supercomputer. My discovery of practical parallel supercomputing made the news headlines because it was akin to discovering an undiscovered continent of the unknown world of the new computer and the new internet. The use of 64,000 human computers to parallel process the weather was published as a science fiction story back on February 1, 1922, and published in the book titled Weather Prediction by Numerical Process. The contribution of Philip Emeagwali to the development of the computer is this: I upgraded parallel supercomputing from fiction to non-fiction. So for 67 years onward of 1922, parallel processing was the big and unanswered question of the field of computing, and for that reason, the quest to answer it was described as the grand challenge problem of the field of supercomputing. For 67 years onward of 1922, mathematical scientists attempted to solve the toughest initial boundary value problems and to solve them by dividing each into smaller problems that could be parallel processed with one problem to one processor correspondence and mapped onto 1 million identical processors that were tightly coupled to each other. Until my discovery of the 4th of July 1989, progress in solving such grand challenge problems and solving them by parallel processing them was a modest factor of 8. That factor was erroneously decreed by Amdahl's law of diminishing returns expected from the increase in the speed of supercomputers. My contribution to supercomputing is this: I figured out how parallel supercomputing works, and that discovery changed the way we look at the supercomputer that occupies the space of a soccer field and changed the way we look at the fastest computer that can be placed on your desk. The computer is a machinery that performs fast calculations. The massively parallel supercomputer is the fastest computer. The Philip Emeagwali Internet is a global network of commodity off-the-shelf processors that were identical to each other, that were tightly coupled to each other, that were equal distances apart from each other, that shared nothing between each other. Each processor operated its own operating system. My contributions to knowledge is this: I discovered a new internet that is a new global network of processors or tiny computers that is not a computer per se, but that is a supercomputer de facto. Who invented the internet? The internet has many fathers and mothers, as well as aunts and uncles. But only one father of the internet invented a new internet. The father of the internet should at least contribute new technological knowledge that pertains to the internet, and do so by inventing a new internet. I am called a father of the internet because I am the only father of the internet that invented a new internet. I was asked, when the games are over, how will you want to be remembered? What's been around the longest will stay around the longest. 1 million years ago, our pre-human ancestors counted on their fingers and toes. I believe that in 1 million years, our post-human descendants will count across their million internet. I will be remembered the longest for my contributions to computational mathematics that changed the way we count and changed it from counting only one thing at a time to counting 1 billion things at once. I will be remembered for my contributions that changed the way we looked at the computer and changed it from one isolated processor computing only one thing at a time to 1 billion processors, supercomputing for the parallel processed solution of the toughest real-world problems. We remember mathematicians from 3,000 years ago, if and only if their contributions to mathematics is still relevant. We remember Euclid as the father of geometry because geometry is taught in schools. We will remember the computational mathematician that changed the way we count. Since prehistoric times, our pre-human ancestors counted only one thing at a time. I discovered that we could solve real-world problems by counting 1 billion things at once, or by parallel supercomputing the toughest mathematical problems. We will remember the father of the internet, if and only if the internet is still relevant in year million. I am the only father of the internet that invented a new internet. I will be remembered as the first parallel supercomputer scientist that came of age on the 4th of July, 1989. That is my legacy and my contribution to human knowledge that changed the world of computers. I was inducted by the United Nations into its gallery of prominent refugees. The United Nations distributed posters of Philip Emeagwali to refugee camps in Kenya, Rwanda, and Sierra Leone. And I was getting emails from those refugee camps inviting me to visit their camps. What is Philip Emeagwali famous for? I became known by word of mouth and as follows. In 1989, a 12-year-old wrote a school inventor report on the contributions of Philip Emeagwali to the development of the computer. That school inventor report is discussed with her classmates and at her family dinner table or during conversations with her younger friends. The following year, those younger friends are more likely to write school inventor reports on Philip Emeagwali. That word of mouth spreading of school inventor reports and its stickiness is more effective than media mentions. Often students forget how to spell the name Philip Emeagwali, but they have no problem remembering to search for the Nigerian who invented the fastest computer, or the African who invented a new internet, that is a new global network of processors. I became known via newspaper and magazine articles that were published after my discovery of practical parallel processing, practical parallel supercomputing that occurred on the 4th of July 1989. I discovered practical parallel supercomputing and discovered it as the vital technology that will make the supercomputer super. The first audience to discover my story were American school children writing school reports on the theme famous mathematicians and their contributions to mathematics, or great scientists in history, or great inventors and their inventions. Some of those children wrote school reports on Philip Emeagwali and did so in part because their father or mother wrote a school report on Philip Emeagwali. The second audience that discovered my contributions to science were Nigerians and Africans in the continent and in the diaspora. Shortly after the Christmas of 1989 in San Francisco, California, the office of the largest technical organization called the IEEE, as well as some other institutions, issued press releases that announced that I had discovered practical parallel supercomputing and discovered it as the vital technology that will power every supercomputer, and that I had invented how to harness 65,536 processors to solve the toughest initial boundary value problems arising in mathematical physics, and that I had discovered how to solve that grand challenge problem and solve it at the world's fastest supercomputer speeds, and that I had solved the problem at the then unheard of speed of 3.1 billion calculations per 3.1 billion floating point arithmetical operations per second. Those 1989 press releases of my discovery of practical parallel supercomputing were picked up by newspapers and magazines, and I began getting requests for media interviews. For the decade preceding 1989, I was mocked and made fun of while I worked alone on parallel supercomputing. But as I became famous, those vector supercomputer scientists that mocked and made fun of me and that refused to work jointly with me and become my co-discoverer of practical parallel supercomputing turned around and insisted that they will now become my new best friend and that I should allow them to become my co-inventors. Their motive was this: if they had collaborated with me and did so for only 1 minute, they would have gone to the court to fight for a share of the credit for my invention of practical parallel supercomputing and for the invention that I had already invented without any contribution from them. In the old style of supercomputing, the conventional supercomputer solves grand challenge initial boundary value problems arising in extreme scale computational physics and takes forever to solve them in a step-by-step fashion that is called serial computing. On the 4th of July 1989, I discovered a new way of solving those grand challenge problems, namely chopping them into a million smaller, less challenging initial boundary value problems, and then simultaneously solving them across a million processors and solving them in a one problem to one processor corresponded mapping that will result in a million-fold speed increase. I visualized my processors as identical to each other and as equal distances apart from each other and as interconnected by identical email wires that were lying on the surface of a globe that was represented by a hypersphere in a 16-dimensional hyperspace. In my July 4, 1989 physical parallel supercomputing experiment that made the news headlines in 1989, I divided the grand challenge initial boundary value problem of simulating the flow of crude oil, injected water, and natural gas across an oil field that is 1 mile deep and that is the size of a town. I did so by dividing that oil field into 2 raised to power 16 or 65,536 smaller oil fields. I emailed my supercomputer codes and their companion data that I used to simulate each of my smaller oil fields and emailed them to and from 16-bit long email addresses. And I emailed them along 16 times to raise to power 16 email wires. That is, I emailed my data and codes across a new internet and into each processor within my new global network of 64 binary thousand processors that were equal distances apart and that were on the surface of a globe in the 16th dimension. That was how I solved the grand challenge problem of supercomputing and how I discovered how parallel process makes the computer faster and makes the supercomputer fastest, and discovered how to always manufacture the world's fastest computer and do so with the technology of massively parallel processing. I was born on August 23, 1954, in a small hospital in the British West African colony of Nigeria. The first house that I lived in was the boys' quarter of a small house for servants that was associated with a big house that was at the intersection of Oke-Emeso Street and Oba Adesida Road, Akure, Nigeria, British West Africa. My mother, Inyamma Agatha Emeagwali, had just celebrated her 15th birth date and did so 6 days before I was born. The precursor to the modern computer was 8 years old when I was born. In 1954, the British colony of Nigeria had a population of 40 million and then had only 150 lawyers, 160 medical doctors, and 1 trained engineer. When I was born, the word computer was not in the Nigerian vocabulary. Even in the US, the word supercomputer was not in the vocabulary of computer programmers of 1946 through 1967. The word supercomputer was first used in 1967.
Insightful and brilliant lecture.